Let's do a third example of how to graph inequalities. The first thing we have to do, though, is write the inequalities from our word problem. We're going to let x be the number of rings we can make, y be the number of necklaces we can make. For this problem, rings will take 4 hours to produce, necklaces 2 hours to produce. Rings use 10 grams of metal, while necklaces will use 25 grams of metal. The first thing we need to do is write an inequality to represent the number of rings that can be made in a 40-hour work week or less. Well, let's see. We can't make a negative number of rings, so 0 is less than or equal to. It takes 4 hours to make a ring, so 4x is less than or equal to 40 hours. Divide everything by 4. And apparently, I could make as few as no rings, or as many as 10. Next, we need to make the inequality to represent the number of necklaces we could do in a 40-hour work week or less. Necklaces, again, take 2 hours to produce. So I can't make a negative number, and because it's 2 hours, it's 2y is less than or equal to 40. We'll divide everything by 2. So 0 is less than or equal to y is less than or equal to 20. So apparently I can make anywhere from 0 to 20 necklaces in a 40-hour work week, if that's all I make. But now we need to write an inequality that represents the total number of rings and necklaces that we could make in a 40-hour work week. I'm going to go back to my original information in each. So 4x plus 2y, because total is an indicator of adding, is less than or equal to 40. I could do this in slope-intercept form. Y would be less than or equal to negative 2x plus 20. Or I could make this much easier to graph by finding the intercepts by plugging in zeros. If I plug in a 0 for x, then the 2y is less than or equal to 40, so y would be 20. If I plug in 0 for y, 4x is less than or equal to 40, so the x would be 10. Well, this time I'm not done. Now they also want us to write an inequality to represent the numbers of rings and necklaces that we can make using 500 grams of metal or less. Well, let's see. Rings were worth 10 grams. So 10x plus necklaces took 25 grams. 25y is less than or equal to the 500 grams of metal we have to work with. Again, I could put this in slope-intercept form. Let's see, 10 over 25, both divide by 5, so that's a negative 2 over 5x. 25 into 500, well, there's 4 quarters and a dollar, $5, that must be 20. Or, the easy way again, just like I found intercepts here, I could find intercepts for this one. If I plug in 0 for x, this goes away. 25 into 500, well, that's what I did over here, that's the 20, so that makes sense. If I plug in 0 here, 500 divided by 10, 50. So my intercepts would be at 0, 20, and 50, 0. Let's graph all these constraints. Here's all the constraints that we're going to have to graph this time. We're going to get 2 vertical lines from the x equations. We're going to get 2 horizontal lines from the y equations. We're going to get a diagonal line from this one because it has both an x and a y. And we're going to get another diagonal line from this one because it has both an x and a y. Let's see what it looks like. So here's what the first 4 constraints look like. Here's my 0 and 10 x equations. Here's my 0 and my 20 y equation. Here and here. Now let's add in the blue diagonal constraint. Okay. When we add in the blue diagonal constraint, it created a triangle. And because it's a less than, we would shade below. Then I added in this other purple diagonal constraint. We would also shade below that. The only place they all overlap is this triangle. So now, based on this, we can label our corner points. I have 0, 0, 10, 0, and 0, 20. This made a nice clean triangle even though there were 6 constraints.